Today we're going to look at different properties of chords. Remember, chords connect 2 points on a circle. So the first theorem is that in the same circle, or in congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So in this, arc AB is going to be congruent to CD if and only if segment AB is congruent to segment CD. If a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. So if the diameter KR is perpendicular to chord IN, then IT is congruent to NT and arc IT, or sorry, IR. Is congruent to arc NR. This one will be if KR is the perpendicular bisector of chord IN, then KR is the diameter of the circle. So the perpendicular bisector of a chord is a diameter, or a radius. In the same circle, or in 2 congruent circles, 2 chords are congruent if and only if they are equidistant from the center. So in this diagram, it would be that FG, arc FG, is congruent to arc HJ if and only if AO is congruent to BO. These are equidistant. These are the same things, just with pictures, so I'm going to mark up these pictures a little bit. So this one is that my arcs, my minor arcs are congruent if and only if their corresponding chords are congruent. So these 2 arcs would be congruent to each other. If a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. In a circle or congruent circles, 2 chords are congruent if and only if they are equidistant from the center. I just saw they have 1 mark already, so we'll add 2 there. Alright, so for this first one, I noticed that these 2 minor arcs are congruent, which means that these segments are congruent. So before I even read the question, I noticed that. So AB is 5x, CD is 3x plus 6. So since those 2 chords are congruent, we can set them equal. 5x equals 3x plus 6. So x equals 3. And it wants me to find AB and CD. Those are going to be equal. So 5 times 3 would be 15. Looking at the next one, I notice I have 2 arcs that are congruent. So that means their segments are, their chords are congruent. So 12x minus 2 equals 34. Notice there are a whole bunch of numbers. I didn't use it all in this problem. So sometimes they have those, and that's called a distractor. doesn't mean you're going to use every single number. So x equals 3. Given that chord BC is 15 centimeters away from the center of circle A. So the chord is 15 centimeters away, which has a radius of 25 centimeters. So remember, going from the center to the edge is 25. I want to find BC and DE. So DE I can find right now because the whole distance of my radius is 25 and a piece of it is 15, so that's going to give me 10. Then what I need to do is do the Pythagorean theorem on this right triangle. So 25 squared equals 15 squared plus x squared. And when I do all that solving, I'm going to get that x equals 20. So that means BC is double that, which would be 40. I did that really fast in my head because this is a 3, 4, 5 right triangle, but everything has been multiplied by 5. So 4 times 5 is 20. Or you could just do Pythagorean theorem. But those 3, 4, 5 triangles come in handy. Alright, this one is going to require me to do a little bit more work. Because what do we have right here? We have a 30, 60, 90 triangle. 6. Okay, so in my table, we have x root 3, 2x. They gave me opposite 2x, which means x is 3. And across from 60 is going to be 3 root 3. So AD, did they ask for that? Yep. AD is 3 root 3. CD is 3. And the measure of arc AB. Okay, we haven't found that yet. So I need to find the whole AB, but I can find that this is going to be the same measure as my central angle that intercepts it, so that's 60 degrees. And the theorem we looked at said that this is going to make these two arcs congruent, so this is also 60. So measure of AB is 120 degrees. So in circle FA, FG is 3, which also means that GH is 3. GA is 5, which also means that PG is 5. And AH is 4, which means that FP is also 4. So what do they want us to find? Find PJ. So PJ is here, and that's going to be 4 times 2, which would be 8. LA is also going to be 8. So they actually gave me really a lot of information there. They could have just given me, say, the 3 and asked me, the 3 and 5 and asked me to solve for 4 by using Pythagorean theorem. So that probably is going to be more normal. Okay, last one. In circle A, FG equals 3x minus 4, and HJ is 14. Find the value of x. Well, since LA is congruent to AP, and these are perpendicular, that means that 3x minus 4 equals 14. So 3x equals 18, and x equals 6.